Today's topic is transportation and assignment problem is some special cases. We have already discussed about how we obtain the solution of initial basic feasible solution of transportation problem using Vogel's approximation method, northwest corner method and least cost method, and optimum solution for transportation problems by using modified distribution method and stepping stone method. As well as we have already discussed about how we obtain a solution of assignment problem using Hungarian algorithm. Now, I am going to discuss some special cases where these methods we need some modification before applying these methods. The first type of such special case is maximization problem. Second, which would be discussed, will be prohibited or restricted route problems, and third one will be alternative optima. So, what is the maximization problem and how we deal with it in transportation or assignment problems? So, for both transportation and assignment problems, the method for obtaining optimum solutions are defined for minimization type problems. That is, either cost or time should be minimized. So, these methods are defined for minimizing costs or times or etc. other things. But in some situation, we have profit or we have sale or other things. In that situation, these methods are not directly applicable, but these are applicable by made certain modifications. So, in case of maximization problem, we can convert the maximization problem into the minimization problem using any of following two methods. Method 1 states that multiply all the profits in the transportation table by minus 1. It may be in transportation table or in assignment table, whichever be the problem. If transportation problem, then all profits will be multiplied by minus 1 in transportation table. If there is assignment problem, then each and every entry in the assignment matrix will be multiplied by minus 1. Similarly, second method said that find the maximum profit and subtract each quantity or each profit from it. By using these two methods, we can convert maximization problem into the minimization problem. We have to use only one of these two, not both simultaneously. If you use both simultaneously, then that will create the problem. So first, I have taken the example of transportation problem in which the table shows the per unit profit obtained by transporting the goods from different origin to different sources or different destinations. So here these quantities are profit, so it is a maximization type problem. So it should be converted into minimization type problem. So first, how we convert into the minimization type using method 1, we multiplied each quantity by minus 1. So that is 42 will become minus 42, 27 will become minus 27, 24 will become minus 24 and 35 will become minus 35. Supply and demand will not be multiplied. So in this manner, like this. Similarly, second row will also multiplied by minus 1 and third row will also multiplied by minus 1. So now this problem is become minimization type problem, and the methods defined for transportation problem are applicable on this matrix. Similarly, when we apply second method, then we have to find first the maximum profit. So in these 12 units, 42, 27, 24, 35, 46, 37, 32, 32, 40, 40, 30 and 32. Among these 12 quantities, 46 is maximum. So each and every unit is subtracted from 46. So for it will become 46 minus 42, that is 4. It will become 46 minus 27, that is 19. This quantity will become 46 minus 24, that is 22. Similarly, this will become 11 and so on up to this one. Last one will become 14. So that is how we obtain. So in this manner, now this will become your minimization problem, and you can apply northwest corner rule, Vogel's approximation method, least cost method, or modified distribution method, or stepping stone method on this table. But after obtaining the optimum table or optimum solution, when you calculate total profit or maximum profit, then you use first table which is given in the question or which is given in the problem. That means suppose you get here 80 units. Then in this situation here you will not use 4. Here you will use 42 for calculating the profit and so on. Similarly, one example of assignment problem. Here four salesmen are to be assigned to four districts. The estimated sales per month in lakh rupees are given below. So estimated sales is given. Sales should also be maximized, then company will get profit. So it is also the problem of maximization. In same manner we apply in transportation problem, we can apply the method in assignment problem also. So using first method, each and every unit should be multiplied by minus 1. So here you would obtain minus 320, here 350, here minus 400, here minus 280, and last unit will become minus 350 in such manners. So here it is the minimization problem. But sometimes there will be problem by when we find minimum and next minimum of row and columns and take difference, then sometimes it will create problem. Some persons take minus 400 is minimum and minus 350 is minimum, whereas someone's ignore the minus sign and said 280 is minimum, so minus 280 will also be minimum and next minimum will be 320. So calculation will become wrong. So it is better to use second method. In this method, maximum profit or maximum sale will be each and every unit will be subtracted from the maximum sale. Here maximum sale is 420. So each and every element will be subtracted from 420. So it will be first element will become 420 minus 320, that will 100. Next will become 70, that is 420 minus 350. Third one will become 20 and fourth one will become 140. Similarly, last one will become 70. So in this manner, you would get the maximization problem is converted into the minimization problem. Now it is easy to see the which one is minimum and which one is next minimum. Here you can easily see 20 is minimum and 70 is next minimum. Then you can easily take the difference. Here you can by chance mistake in selecting the minimum and next to minimum, as well as you can mistake in the sign of the difference when you take maximum difference. So I would suggest to use method 2 is better than using method 1 for assignment problem as well as for transportation problem. Now Hungarian method can be applied on any of two obtained cost matrices or assignment matrices. Now second problem is called as prohibited or restricted problem. In case of transportation problem, due to some reasons, goods cannot be transported from a particular origin to a particular destination. So there will become a restriction that from origin A to destination 1 we cannot supply a particular good. There may be certain region A is very much far from one, or there is some issue with the distributor and among distributor and supplier. So that supply cannot be made. So such problems are called as prohibited or restricted route problems in case of transportation problem. So to solve such problems, we put infinity for the pair of origin and destinations for which restriction is given. That is, to solve such problems, the cost of transportation for the restricted pair of origin and destination is taken as infinity. When we consider the cost as infinity, there will no allocation. Similarly, in assignment, due to some restrictions or other problems, a particular job cannot be assigned to a particular person. So you can consider man can perform a work manually to in very much good manner, but he is not familiar with using the computer. Generally, old age persons can perform work on papers very well, whereas they cannot perform work on computer quite easily. So we can, if there will be a computer work, then we cannot want to assign that work to the old age persons as they are not familiar to the computer. So in such situation, there is certain restriction. So sir, these restrictions, due to these restrictions, assignment problem is called as restricted or prohibited assignment problem. To in same manner as transportation problem, to solve such problem, the cost of assignment for restricted pairs of job and persons will be considered as infinity, and problem is solved using Hungarian algorithm. For example, I have considered this example: three refineries with maximum daily capacities of 6, 5, and 8 million gallons of gasoline supply three distribution area with daily demands of 4, 8, and 7 million gallons through a network of pipelines. The transportation cost in rupees per 100 gallons is given below. Due to certain region, the refinery 1 cannot supply to area C. Find the optimum solution to the problem. So here you can see it is mentioned, due to some region refinery 1 cannot supply to area C. That is, this supply cannot be made. So here instead of 200 we take infinity. That is, problem can be written as in this manner. So here you can see 200 is replaced by infinity. You can use infinity or you can use dash instead of any cost. That is, you can left blank the this cost also. Then after replacing it, we can apply any method. So I have solved the problem first obtaining the initial basic feasible solutions using Vogel's approximation method. After applying Vogel's approximation method, this table is obtained. Then obtain the optimum solution. The optimum solution is obtained by using modified distribution method, where we calculate ui, vj, and net evaluation. So here the calculation of ui and vj is given. Here cost is taken as, sorry, ui is taken as 0. So vj will become 200. Similarly for this, it will become 120. Now from this we go to this one, then here cost is 80, so ui will be minus 40. Similarly, other calculations are made. uia and vj's are calculated by you solving the equation ui plus vj is equals to cij. So using that, we can easily obtain ui and vj. Then we obtain net evaluations, which are denoted by zij minus cij, which is equals to ui plus vj minus cij for unallocated cell. So first unallocated cell is this one. So here net evaluation will be 140 plus minus 80 minus 180. That is 140 minus 260, which will give minus 120. Similarly, here is infinity, so net evaluation will become minus infinity automatically. For this unallocated cell, ui is 200, vj is 200, ui is minus 40. So net evaluation will become minus 40 plus 200 minus 300, which will give minus 140. Similarly, not last net evaluation is here, which will become minus 110. So we can see that all the net evaluations are non-positive. So this solution is optimum. And here you can easily check that no allocation is made in the restricted pair. That is, no unit is transported from 1 to C. Now you can calculate easily the cost of supply, which will comes out to be 2320 million rupees, or it will be in thousand. I have taken is per unit cost, whereas it is given as per 100 units cost for per 100 units, so it will be in 1000 rupees. Similarly, in assignment problem, I have taken one another example. So here assignment costs are given. So problem is minimization type. Then it is given find the optimum solution under the condition that operator 1 cannot operate machine C as well as operator 3 cannot operate machine 2, machine D. So here you can see there are two restrictions. One is between pair 1 and C and other is between pair 3 and D. So here on two places we put infinity in place of cost. So assignment matrix will become this type. Here infinity occurs between 1 and C, and here between 3 and D infinity occurs. Now using Hungarian algorithm, first we subtract minimum of row to next minimum, then find minimum and next to minimum in the columns and take the difference of that, and applying the different steps we obtain this matrix. And we can draw now the lines. Here you can see the number of lines are equal to the order of the matrix, so it is optimum assignment matrix. And in place of infinity, infinity is put at up. That means these will not be assigned. When we can consider assignment matrix, here you can see 1 and C and 3 and D are here, no zero is available, so these will not be assigned. Now assignment should be made. So these are assignments are made of assignment. The making of assignment. So here you can see 1 is assigned to D, 2 is assigned to C, 3 is assigned to machine C, and 4 is assigned with machine A. So it is clear that machine C is not assigned to operator 1 as well as machine D is not assigned to operator D. So in this manner we can easily obtain the solution in case of prohibited or restricted root models. Third case is alternate case of alternative optima. So for transportation problem, when we obtain the optimum solution by using modified distribution method, then there will be some net evaluations which comes out to be zero. Or if we apply stepping stone method, then some of the opportunity costs comes out to be zero in optimum table, not in initial stage or any between stages, in optimum table. Then there exists another solution which have same max minimum cost, and according to that zero and towards that new evaluation which is zero, we can transfer maximum possible quantities without affecting rim requirement to that cell, and it would provide an alternative optima in case of transportation problem. Similarly, in assignment problem, sometimes two or more zeros occur in at same position in two or more rows. Then we make selection of that zeros arbitrarily among the available zeros. In that situation we can get another optimum solution also. That will be case of alternative optimum. So for both, I have taken in this example for the transportation problem, initial solution is given. Using this initial solution, I have used modified distribution method to obtain the optimum solution, and optimum solution is obtained as this one. Here you can see all the net evaluations are non-positive, that is either zero or negative. So this net evaluation shows that this solution is optimum. But here you can see in the cell a comma 1, or you can say 1 comma 1, there is a net evaluation which is 0. So we can transfer maximum possible quantity according to the loop of this. So first we construct the loop of for this cell. This will be considered as entering cell. If there is a 0 in net evaluation, then we can also take it as entering cell. Then we construct the loop. The loop is constructed in this manner. That is cell 1 1 1 4 3 4 and 3 comma 1. Then we assign the quantity theta minus theta alternatively. Then obtain the value of theta by at the places where theta is minimum or theta is negative. So theta on negative thetas there are two quantities 40 and 85. Among these minimum is 40, so 40 units will be transferred. Where theta occurs, the quantities are added, 40 is added to the quantity, and where minus theta is present, 40 is subtracted from the quantity. So here we will obtain 40, cell 1 comma 4 will leave, that is it will become 0. Here we add 40 and here we subtract 40, it will become 40, 0, 45 and 45. That is this table is obtained. Now you can easily check the optimality of this table by calculating net evaluations and also verify that the cost optimum cost for both the transportation problem, that is alternative solutions, the optimum value is 1160 units. That is for this table and for this table. For these two tables the optimum cost is same and it is which is 1160 units. In same manner, in the case of assignment problem, I have taken the example of 5 cross 5 matrix where 5 brands are packed. 5 brands of snacks are manufacturing using 5 different manufacturing setups and cost is given. Then Hungarian algorithm is applied on this and this matrix is obtained for the solution. When we make assignment, here this 0 is selected, then this one is crossed off, then this one is selected, this one will be crossed off, this one will be selected, then this one will be crossed off. But among these two, there are two zeros in same row and same column. So that means two or more zeros are present at same position in a particular column, or you can say in a particular row. So among these zeros, when selection is made, we can select this one and cross this one, or we can select this one and cross these two. So that is first I have made this assignment. So here it is selected arbitrarily. We can also select this one instead of this. So it will provide an alternative optima. So we can here we can take the optimum solution is written and cost of assignment is 27 units. Now we obtain the alternative optima. Here instead of this first zero, I have selected the second zero. That is assignment are made in this manner. That is in first solution B3 was assigned to S3 and B4 was assigned to S4. Now in alternative solution B3 is assigned to S4 and B4 is assigned with S3. But when you see the total cost which is minimum or optimum, then you would see that it is also 27. That is optimum solutions are same. So these are the cases of alternative optimum.